All right, here's our video. Kepler's third law, and the planets. And we're talking about Johannes Kepler. Let's write his name. Johannes Kepler. He lived in the 17th century. Johannes. A lot of people mispronounce his name. So Johannes Kepler lived about the 17th century. No, he was born in the 16th century. And he's famous for his laws on planetary motion. So his laws on planetary motion. And the E got a little smeared over there. And we will talk about his first and second laws in other videos. But for this one, we'll talk about his third law. Circle that, his third law. And let me write it for you. And we'll talk about the equation. We'll go over it. It's t squared equals r cubed. And the t's going to stand for time. And the r stands for radius. So let's explain that a little more. So basically what he's saying is the time it takes a planet to orbit the sun. I'll write that down. That's what t is. So t equals the time it takes for a planet to orbit the sun. And of course, if you see the equation, we're going to square that. Once we know what that is, we'll square it. So the time it takes for a planet to orbit the sun is proportional, that means it's equal to the distance. And by the way, the time squared, like you see it here, the time squared is proportional to the distance. And we're going to say cubed. The distance cubed is right here. And what we mean is the radius, right? The distance from the sun. So the time it takes for a planet to orbit the sun, the time squared, as you see here, is proportional to the distance cubed. And there's that little cube sign. And we'll go over examples here. So let's go. And before we begin, we need to know a little bit of what AU means. Let's get the pen going. I use red. What AU means, and this word over here I'll write, because this is the radius we're going to be talking about. Remember, it's elliptical. All planets will revolve around the sun in an elliptical orbit, not in a circle. So this radius that we're talking about in the formula, and again the formula is here, t squared equals r cubed, they call this the semi-major axis, as opposed to B over here, the line B, which is, what do you think it's called? The semi-minor axis. But we're going to just concentrate on the radius, the semi-major axis. We also need to know what AU means. It's astronomical units. And it's centered around the sun and Earth. In other words, how far Earth is from the sun. And we say that Earth to the sun, the radius, is 1 AU, which is about 93 million miles. 93 million miles. So it's all centered on the statistics of the Earth. So any other planet we'll use AU. So again, the Earth does have an elliptical orbit. And so like let's say we were using this here. Let's clear this out. If we were using this and this was the Earth, let's say in the wintertime. In the wintertime, Earth is actually closer to the sun. It's 94 million miles. And in the summer, put the summer over here, the Earth is 95 million miles away from the sun. So that's where we're getting the 93 million miles. And of course, that happens with all the other planets. So let's use this equation now. Let's start with Jupiter. All right, I'm going to use yellow. Let's use yellow. All right, so let's write Jupiter. Jupiter over here. And we'll get the formula t squared equals r cubed. And now Jupiter doesn't exactly orbit the sun. So that's something we should know about. It doesn't exactly orbit it. It's actually the sun and Jupiter are actually orbiting a common center of gravity, which I'll talk about in another video. But for now, just for this equation, we'll just have Jupiter orbiting the sun. So it takes Jupiter 12 years to perform that orbit. 12 years. So we have t already. We know t equals 12. But we don't just want t, we want t squared. So that'll be 12 squared. And 12 squared is 144. So we have that part already. And we want 144 to equal r cubed. Now, since we have r cubed, let me just give you, if you don't know what cubed means and cube roots, let me just give you one. You can skip this part. So let's say I said the cube root of 8. Well, the cube root of 8, we want a number, that same number multiplied 3 times that can give us 8. Well, the cube root of 8 is 2, right? Because 2 times 2 times 2 is 8. So here we have r cubed. And in order to clear out r cubed, to just get r, we're going to cube root each side. Cube root each side. So the cube root of r cubed here would just give us r. So now we have our r. Now we need to know the cube root of 144. And now you can use your calculator. Now, if you don't understand the math too much, just remember that if you see a 3, then cube root it on both sides. Again, you should know a rule in algebra. Whatever you do to one side, you should do to the other. So as you see, I cube root one side, I'm going to cube root the other. Simple as that. And the cube root of 144 is about 5.2. So that is in AU. So remember, 1 AU was about 93 million miles. The distance Earth is on average to the sun. And Jupiter is 5.2, which gives us about 484 million miles. Well, let's do another one. Let's do Saturn, see if you're getting the hang of this. I'll clear this out. All right, let's do it again. Let's write t squared equals r cubed. Now, let's give you r cubed this time. Let's say, well, we know that Saturn is about 886 million miles away from the sun, which is 9.5 AU. So we already have this answer. 9.5 is r. 9.5 equals r. It does not equal r cubed. So we're going to say t squared equals 9.5 cubed. Because remember, 9.5 is r. T squared then will equal about 857.375. You do that on your calculator. So here now we have a 2. We have a square. So how are we going to get a t by square rooting this time? Not cube rooting, square rooting, because it has a 2. And whatever you do to one side, do to the other. So you have to square root 857.375, and you'll get 29 years about. You'll get more than that. You'll get like 29.28 years. So we know now that Saturn is 9.5 AU away from the sun. That's the radius. And its orbit takes about 29 years. A little more than that. All right, let's do one more. Let's do Mars. And we'll clear it out. Keep yellow, why not? So what's the formula? What's Kepler's third law? You can tell me now. That's right. T squared equals R cubed. You got it. And we'll do Mars. So Mars takes 687 days to orbit the sun, which is about 1.88 years. 1.88 years. So what do you have? You have the orbit time, right? You have the orbit time, right? You have 1.88 is t. But we don't want t. What do we want? Want coffee? No, we want t squared, right? So we're going to say 1.88 squared equals what? R cubed. And what is 1.88 squared? Well, just do it on your calculator, right? It's about 3.5344. So now we know what that is. That has to equal R cubed. And here's that cubed again. So how do we get rid of a cube? How do we just get R? Do you remember what we did? We cubed root. We cube rooted each side. Cube root that side. That means we have to what? Cube root this side. So what do you think you get? What is the distance Mars is from the sun? Well, if you did this, if you want to pause the tape and get the answer, we know that it'll be about 1.52 equals R. And what is 1.52? 1.52 AU. And it makes sense, right? Because Mars is further out than Earth. All right, that's Kepler's third law.